Yeah.
What he did in 1873, he published a paper on New England boletes. He happened to describe some of the most iconic boletes that we know in Northeastern North America. That's one. But instead of naming it for himself, he had a friend named John Russell. He lived in Boston. So John Russell is the authority of Boletes Stroudsburg. In turn, he named another bolete for his friend John Russell that we know as Boletes russellii, which we don't have out here. But again, a second iconic bolete. Here's a third one called Boletes pallidus. It's a very pale colored one. It's dry. And what's interesting about it is it has yellow tubes that stain blue. And I don't know anything about edibility because I don't eat these guys. I just study them. Okay? But here's a third iconic taxon that Frost described in 1873. So it looks like it might be an eduloid thing because it's pale, it's dry, it's got a pallid stipe, but the pores stain blue. What else? This one is a very irregularly pitted cap, pale cinnamon brown. And Charles Peck described this one, who was a state botanist in Albany for 35, 40 years. But he called it Boletes corugus. Well, that name happened to be used, he called it Boletes subclavipes variety corugus. Turns out that people thought, oh no, this needs to be its own species. So the name corugus had already been used before in Boletes. So Alexander Smith and Harry Kears decided to call this as a separate species, and they named it Hortonii. Horton is Charles Peck's middle name, so that's how he gets the name Hortonii. And it probably isn't a Boletes, although that's where it's been placed now. And when people get done playing with DNA and so on, it may actually turn out to belong in some other genus in the Boletes. Oh, Walt said he talked about Chrysanteroides. There is something called Chrysanteron, and it's one of those little brown, it can be bigger than this, but it's got a dark red stipe, gray-brown cap that often cracks, like this, see? And sometimes in those cracks it'll stain red. And this belongs now, you've heard the genus name Xerocomus. All right, this would often be placed in that genus Xerocomus because it's built differently than true members of Boletes. If you think of Porcinis or Edulis, those are the real species that belong in Boletes. Ones like this are built differently, and I mean by that, if you try to take the tubes apart, they don't split very well, and it's because of the way that it's built, all right? The way the hyphae are arranged in the tubes. And with the DNA and all that jazz, yeah, that seems to support what we can see in terms of how the thing is constructed. Now, Chrysanteroides was described with that name by Walter Snell because he thought it resembled Chrysanteron. It does to some degree, but the other thing about Chrysanteroides is that it doesn't have smooth spores. It has the ridges along the length of the spore, and that's why it's in the genus Boletes. Oh. Did Walt talk about Philipporus?
Yes.
Yep.
Okay, but maybe Walt sort of finessed my question, which is some people say they aren't gills, their pores arranged differently. Is a construction a
Could you say that louder?
The question, my question was, some mycologists or in some field guides, they say that the gilled bolete, that they're not gills, they're just pores arranged differently. So I'm not sure what the difference is between a gill and a pore arranged differently, or why you would describe it that way, that's all.
Yeah. Now, if you look at the microscopic structure of a Philipporus, you can see that it's built the same way internally as a tube if you look, how can I?
A good coffee cup.
No.
Yeah, the tubes are.
If this is a gill, okay, and if this is a gill, and you cut a section out of it through here, and you laid it down, and this is what you would be looking at on the microscope slide. So all the basidia are sticking out on the side of the gill, yeah? So this is the section from that gill. So the basidia are sticking out here. In this internal space that supports the basidia, the arrangement of the hyphae in there are arranged in the same way as if you had taken a tube and taken a section out of the inside of the tube. So in this case, all the basidia are oriented to the inside of the tube, yeah? So if you take that piece and again lay it out, the basidia are on the sides of the tube, but that internal structure, the hyphae that support the rest of it, the hymenium, is constructed in the same way as a Philophoros. Now, Alan Bissett showed a picture last night of a Philophoros that was called Boletenoides. In that picture, you could see gills, but then you could see partitions between the gills. So it was partway between being a pore and being a gill. An example is in this Boletenellus. If you look at it, you say, you can see some kind of gill structure there where gills are going from the margin towards the stipe. But you also see cross gills, attachments that go between what look like irregular gills. Yeah? So that's why this arrangement is often called boletenoid. That's a 50-cent term you can take home with you now. So this arrangement of the hymenophore called boletenoid, hence Boletenellus. See how that comes about there? And in the name of that Philophoros last night, Boletenoides. All right? So it's the structure, the anatomical structure that makes up what supports the hymenium. Furthermore, when you look at the spores, the sterile cells, the chemistry of Philophoros, it's the same as other poroid boletes like Chrysaneron. As a matter of fact, Philophoros is more closely related to the xerocomus-like boletes than it is to others, the other boletes like Edgulus and so on. We'll talk about Boletes griseus. Here's another one described by Frost or Peck. I don't remember. One of those guys. Anyway, early on. But it's one of those distinctive ones that has a very, very conspicuous reticulation on the stipe. It's got a little bit of yellow in the base, but it's got a gray cap. There is some chemistry that was only done a few years ago that relates this one with another species called Ornatopes, a species I described from Costa Rica called Flavoniger. And so you've got those three, griseus, Ornatopes, and a southeastern one called Retipes plus Flavoniger. There was a bolete chemist in Germany who was interested in looking at these things because she found that there were some unique chemical compounds only found in those 4 different species. So she got to describe a new chemical, a new molecule from the boletes that are called retipolides. Yeah, I don't even know what it looks like. I can see, ring structures and carbons and hydrogens and whatnot on a piece of paper. But in any event, what's interesting about that group is that it's it's unique just among a small group of boletes. Then, at that time in Germany, Manfred Bender was working on doing DNA molecule extractions and doing all the molecular phylogeny. It turns out that those 4 species were completely separate from all the other boletes in a completely different group altogether. But one of the things they shared in common were the retipolides and these very coarse reticulated stipes. And so they described a genus that they called Retiboletes. So those, at least those four, belong in a separate genus called Boletes. So if you see that name, don't scratch your head. Now you know the story. Right? You can go home and impress your neighbors and friends. Where did that come from?